Alright, good morning. Today we're going to talk about Math 111, and in particular section 5.9 in our text, which is entitled Solving Equations by Factoring. You may have asked yourself, you probably should have asked yourself at this point, why do we spend so much time factoring in chapter 5? And the answer will be revealed in this, section 5.9. Well, in chapter 2, you may recall we could solve what I call degree 1 equations. In other words, the highest exponent you see on any term is 1, meaning a degree 1 expression involved in the equation. Alright, well, we know how to solve degree 1 equations. Well, we add and subtract and multiply and divide, in other words, to isolate x on one side of the equation. Alright, so solving degree 1 equations is no sweat. So let me write that down. We solved degree 1 equations. Alright, let me motivate today's lecture with a problem I'm going to pose to you. Let's say I want to solve a degree 2 equation. Well, the idea here is because these are unlike terms on the left, they cannot be combined. Well, that means you cannot isolate x on one side of the equation using the techniques of chapter 2. Right? Now, if we add 3x to both sides, if we divide both sides by x, there's no way you can isolate x by the techniques used in chapter 2. Let me write that down. So we cannot, using either addition or multiplication or division or subtraction, you cannot isolate x as in chapter 2. So what we need here is a new technique. Let me pose to you another question. I'll give you a very simple degree 2 equation. Alright, so we've got a degree 2 term, a degree 1 term, a degree 0 term, added up and equaling 0. So we've got a trinomial expression equaling 0. Again, x squared and 5x, these are unlike terms, so can't be combined. Alright, so what I'll do is I'll factor the left-hand side. I believe that'll do it. So I'll get the equivalent expression, x plus 3 times x plus 2 equals 0. At this point, I'm going to invoke what I call the zero product rule. And all that means, all that says is if you have a product of factors equaling 0, that means either one or the other is 0. Alright, so that's not too unbelievable. We can accept that pretty easily. And what I can do is take this rule and apply it to this expression here. I've got a product of factors equaling 0, so then I can set each factor equal to 0 independently, and this results in two degree 1 equations. We started out with a degree 2 equation, and using the zero product rule, we can branch off to two degree 1 equations, which now I can solve as in chapter 2 very easily. So I've got two solutions here, x equals minus 3 or x equals minus 2. Alright, so in wide strokes, this is kind of how section 5.9 is going to go. So we can answer the question why we spend so much time factoring in chapter 5, and the simple answer here is to solve equations of higher degree. And by higher degree, we mean by degree greater than 1. Okay? Let's do another example. solve 3x squared equals 6x. Alright, this is a degree 2 equation. It contains two monomials. One of them is a degree 2 monomial, so I call this an equation of degree 2. Almost always it will benefit you to first convert to standard form, and by that I mean arranging your terms in decreasing degree. So typically what we do is arrange the variable terms on the left hand side in decreasing degree. So for this given equation, I'll subtract 6x from both sides. I'll have my terms in decreasing degree on the left and equaling 0 on the right. That's very important. Alright, now I'm going to factor. Well, there is a GCF of 3x in this equation on the left hand side, so I'm going to factor out a 3x, and I'll have the remaining expression 3x times x minus 2 equals 0. Alright, what I'm going to do now is invoke my zero product rule. So a degree 2 equation branches off into two simpler degree 1 equations, which I can solve for pretty easily now. On the left branch, I'll divide both sides by 3, and x equals 0 over 3. Well, 0 over anything is just 0, as we know. And on the right branch, I get x equals 2. So for that equation, x equals 0 or x equals 2. Let's try another one. Solve 9x squared equals 25. Alright, again I will arrange my terms in decreasing degree and set it equal to 0. So all I need to do here is really subtract 25 from both sides to get it in what we call standard form. And of course I can recognize this binomial on the left as a difference of squares, like we talked about in section 5.7. So I can factor the left hand side as 3x plus 5 times 3x minus 5 equals 0, and then using my zero product rule branch this off. So a degree 2 equation becomes two simpler degree 1 equations connected with an OR statement. So on the left branch I can solve for x pretty easily now, subtracting 5 from both sides and then dividing by 3. So x equals minus 5/3. On the right hand branch I'll add 5 to both sides and then divide by 3, and I get x equals positive 5/3. So there's my two solutions for my degree 2 equation. Alright, let me get another screen here. Alright, let's go up the ladder. I will ask you to solve another equation. And don't panic, this one's got fractions in it, and it's very far away from standard form. Alright, so probably the first thing I would do here is to multiply both sides, all terms, by 5. Right? The GCF, the least common multiple, I should say, of all these denominators is of course 5. So if I multiply both sides by 5, all the fractions will go away. That's probably the best thing to do first in this particular example. On the right hand side, you've got to apply your distributive law. 5 times 6/5 is of course 6, minus 5 times 6/5 x squared is of course 6x squared. Alright, now I don't have fractions to deal with anymore, so I'm going to now just add 6x squared to both sides and also subtract 6 from both sides, and that'll give me all my terms on the left hand side arranged in decreasing degree and a 0 on the right hand side. Alright, I believe this does factor. Let me try it. I can factor the left-hand side as a trinomial basically by unfoiling it, as in section 5.5. So I'll get 3x and 2x in the first slots. I'll need factors of 6 in the last slot, and I think that'll do it. The outer product here will be 9x, the inner product here will be 4x, and I can play with the signs. Let's see. Oh, I made a mistake. Hang on a minute. Let me erase this. Hang on. Oh, by the way, I'm offering a 5-point bounty on mistakes. Let me write this down. 5 points. Alright, 5 points. If you discover a mistake in the online lecture, 5-point bonus. If you report any errors, if you're the first to report, let me write this down, 5-point bonus if you're the first to report an error in any online lecture or any online class. Okay? Alright, so I did make a bit of a mistake here. This 5x should be positive. Alright, let me check it. If I add 6x squared to both sides, I've got a plus 5x already on the left hand side, and subtract 6 from both sides. That looks good. Okay? Alright, so please beware of the 5-point bonus. Let's go on. Alright, if I factor the left hand side, 3x and 2x in the first slots I think will work. If the outer product is 9x and the inner product is a minus 4x, indeed the inner and outer product do add up to 5x, and the last product is of course minus 6. Alright, so successfully factoring the left hand side trinomial gives me this expression, and now I'll branch off using the zero product rule. 3x minus 2 equals 0, or 2x plus 3 equals 0. I'll add 2 to both sides on the left branch and divide by 3. So x equals 2/3 on the left, or 2x equals minus 3, or x equals minus 3/2 on the right branch. So again, a degree 2 equation with 2 solutions for x. Alright, let's go again, move up the ladder, something a little more difficult. Again, we're going to ask you to solve something that looks like this. Now, don't panic. You've got a square of a binomial on the left, a product of a binomial times 6 plus a constant on the right. Well, the first thing we should do here is convert to standard form. In other words, arrange all your terms on the left in decreasing degree in order to get a 0 constant on the right. Then I can apply my zero product rule. Alright, let me look at the left hand side here. If I square 3x plus 1, I get 9x squared plus 6x plus 1, squaring the binomial. Don't forget about the inner and outer product. On the right now, I'm going to convert this product. 6 times 3x is 18x minus 6. And of course, plus 3, I'll combine like terms in a minute. Okay? Alright, so let me combine like terms now, arranging my terms on the left. So I'll leave a 9x squared on the left. If I subtract 18x from both sides, I'll get a minus 12x on the left. And minus 6 plus 3 is, of course, minus 3. So I'll add 3 to both sides and I get a plus 4 on the left. So combining like terms, crunching things together, getting all the terms over on the left-hand side, I get 9x squared minus 12x plus 4 equals 0. Now that I've got it in standard form, I'm going to try to factor, and I think I see this factoring with 3x in the first slots. Let's see, minus 2 and minus 2. Yeah, that'll work. The first product is 9x squared. The outer product is minus 6x. The inner product is also minus 6x. And the last product is positive 4. Alright, so I will now branch off to 2 degree 1 equations, but notice both of these factors are the same. 3x minus 2 times 3x minus 2. Well, all that means is you're going to have a repeated solution, or a repeated root, or a duplicate root, depending on what book you read. Alright, so if I take this left branch, I'll add 2 to both sides and divide by 3. I get x equals 2/3. Well, if you want to be real formal about it, you'll get the same solution from the right branch. So I suppose you could write this as a repeated root, a repeated solution of x equals 2/3. You don't need to write that down on test day, but I just wanted to show you sometimes it does happen where solutions are repeated or duplicated in a given problem. Alright, let's try another one. Solve 6x cubed minus x squared equals 2x. Alright, now this is a degree 3 equation. Well, we'll solve degree 3 equations like we do degree 2 equations. We'll set them up in standard form and attempt to solve by factoring. Well, remember, you can factor some degree 3 equations factor just like degree 2 equations can factor. Alright, so essentially I'll subtract 2x from both sides as a first step. Arrange terms on the left in decreasing degree. Notice there is a GCF here. Always look for a GCF first. As we've mentioned a couple of times in this chapter. And if I factor out an x first, I get 6x squared minus x minus 2 inside those parentheses. And we can keep factoring here. I think the resulting trinomial in the above step breaks down as 3x minus 2 times 2x plus 1. Let's check it. The first product is 6x squared. The outer product is 3x. The inner product is minus 4x, and those indeed add up to a minus x. And the last product is minus 2. So indeed the factoring looks correct. Let me rewrite that equation down. X times 3x minus 2 times 2x plus 1. Come on. Get the eraser set too big. Times 2x plus 1 equals 0. And notice I have 3 factors. Don't forget about x. X is a factor here also. I have a product of 3 factors equaling 0. So instead of branching off to 2 equations, I'll branch off to 3 equations, connecting them all with an OR statement. 3x minus 2 equals 0, or 2x plus 1 equals 0. Okay? Alright, now all 3 of these branch equations I can solve pretty easily. Notice x equals 0 is a solution, so please include it in your solution set. In the middle branch, I can just add 2 to both sides and divide by 3, so x equals positive 2/3. Or on this right branch, this third branch, I'll subtract 1 from both sides and then divide by 2, and I get a solution x equals minus 1/2. Alright, so here, notice I started out with a degree 3 equation and ended up with 3 solutions for x, and that can happen. Okay, let's do one more example. We'll call it a day. Get a fresh screen. And this is from your homework list, number 81 on page 499. Kind of nasty looking thing. But again, if you show good housekeeping skills and don't panic, I suppose the real battle is to get it in standard form first. Alright, so clearly I've got to do a little surgery here to get it in standard form before I go on. On the left hand side, I'm going to perform this multiplication. I'll get 3n squared minus 4n. How about on the right hand side? Well, if I square n minus 6, I get n squared minus 12n plus 36. And to that I'm going to add 11n and then subtract 1. Okay? Alright, let me crunch things together on the on the right hand side. Alright, n squared, no other n squared term on the left. I can combine these degree 1 terms. Minus 12n plus 11n is minus n, and 36 minus 1 is, of course, plus 35. Alright, so what I can do now is subtract n squared from both sides. I'll get a 2n squared. Let me scroll down a little bit. Similarly, I will add n to both sides. That'll give me a residue of minus 3n on the left. And of course, then subtract 35 from both sides. No constant on the left-hand side, so I'll get a minus 35 on the left and equaling now 0 on the right. Alright, so now we're in standard form. Terms arranged in decreasing degree, equaling 0 on the right. Alright, I think I can factor this trinomial as 2n plus 7 times n minus 5. Let's check it. The first product is 2n squared. The outer product is minus 10n. The inner product is 7n. That indeed adds up to a minus 3n. And the last product is, of course, minus 35. Alright, so let me rewrite that. We've checked that the factoring works. So 2n plus 7 times n minus 5 equals 0. I'll branch off, setting each factor equal to 0. Important to connect them with an OR statement. If you don't, it's wrong. Alright, so I'll subtract 7 from both sides on this left branch and then divide by 2. So I've got one solution of n equals minus 7/2, or, don't forget the or, well, here I'll just add 5 to both sides and I get n equals 5. So again, a degree 2 equation with 2 solutions, minus 7/2 or 5. Alright, we're approaching the 24-minute point, so we'll call it a day. And this concludes section 5.9, solving equations by factoring.